Hi everyone. In this video I'm going to show you how we can create a command line application using Micronaut and GraalVM, which is compiled to a native binary. And for this purpose we're going to use Mastodon. So Mastodon is a social network which is very similar to Twitter. This is typically my timeline. So my account is @melix@mastodon.xyz. So you can see that the username is actually very much like an email address. So there's an alias part, and then there's the second part is the server that you have to, and this is because Mastodon is decentralized, so you have the choice of which server you want to use, but you can still communicate with other servers. So this is my timeline. You can post statuses, retweet, etc., etc. And the goal of this demo is to actually post something from the command line using an application written in Java and compiled to native binary. So let's see how we can do that. So I have precompiled the application that we're going to build in this demo, and let's do this -p to actually -p for post, and we're going to post that, and this is actually going to post that into my timeline. So if we come back to the Mastodon window, we should see now that yes, 30 seconds ago this tweet was posted, right? So this is what we want to achieve today. So how we do that? First things first, we come to Micronaut Launch, which is a web UI which lets you bootstrap some Micronaut projects. So I have prepared all the parameters that we're going to use there. So first, command line application. This is obviously what we're going to build today, but by default it uses Micronaut application, which is a server using Netty. You can use Tomcat if you want, but well, doesn't really matter for the details, but what you need to be aware is that we support many different kinds of applications. So command line application, we're going to come back with the features later. Then you select the language that you want to use, Java, Groovy, or Kotlin. I'm going to use Java 17. Then for the build tool, we're going to use a Gradle Kotlin DSL. I strongly encourage you to use Gradle. It's the developer experience is really much better. Then for the test project, test framework, sorry, we're going to use JUnit, and this is because we can actually run the test natively, and I'm going to show you that. Okay, so couple of features that we use in this project. So first one is the HTTP client. The second one is Jackson. So, well, we use Jackson there for serializing the JSON payloads, and most projects would use Jackson or something else like Bison or whatnot. But Micronaut actually provides an alternate implementation of Jackson, which works at compile time. So you can use serialization Jackson, and what it would do is make it possible to use Jackson annotations in your application, but then at runtime it would not use Jackson at all. It would use classes which are generated at compile time and which only support serializing and deserializing the classes that you annotated in your code. So it's actually safer, it produces a smaller binary because it doesn't use the Jackson runtime, etc., etc. So strongly encourage you to use serialization Jackson instead of just Jackson. The second one is obviously that we're going to use this HTTP client to be able to connect to the server, but we don't want to implement the logic there. We just want to declare that. So we're going to use a declarative client, and let's look at what it's going to show. So say that later you want to add more features there, and that you want to see what dependency you would need to add. You can click on this diff button, and then it would tell you which dependencies you need to add typically for these features that you selected. So you can come back later and edit the build file very easily. For the preview button is basically what the project looks like, but it's going to be easier to show you that in the IDE. And then in the end, when you click generate, either you push directly everything to GitHub, or you can download the zip file containing all the sources. And the last option is to use the command line, because you can have and download a tool called MN, which would do exactly the same thing as what we have there on the UI, but from the command line instead. So your choice. In this case, I chose to download a zip file, which I expanded locally and opened in my IDE. So I'm going to show you that. Here it is. So I made just a couple changes to the build script. The first one is that I added a dependency on JSoup, and this is because we're going to display all those messages on the command line, and this is plain text, and JSoup is going to help us clean the HTML and just produce plain text instead. The second change I've made is to add these arguments to the run task. So if we run Gradle w run, then it's going to add this argument -v. And where that it comes from this main class that we have, which is the Mastodon command line. And it is using Pico CLI as the CLI framework, which is really nice because what it allows you is to basically annotate fields with options. You give the name of the options, description, etc. And then basically if -v is set, then verbose is true. If verbose is true, then we can print this hi thing. So if I do Gradle run, it's going to display hi, right? This is expected, this is what we want. So let's look at the test now that is generated out of the box. You can see that it uses this -v flag, and what it expects is that the output contains hi. So I'm going to change that to French, salut, so that we can see the test failing. So I'm going to run the test. So you can do that either from the IDE. So I can run test, and it's going to compile the application, and we can see it expected true, but it got false. That's expected. Or we can do that from the command line, and that's one of the things that you can do with Gradle. You can do Gradle -t run, and the -t means continuous mode. So not run, I want to test, actually not run. So I'm going to test, and the test is failing. But now if I go there and change and say hi and save my file, then it immediately recompiles and runs the test, and now it passes. So you can do that for test. So if you're a fan of TDD, it's really neat, but you can do that to solve for run. So if you have a server and you make changes in the server, it would be recompiled live, etc., etc. So super neat and super friendly for development. Okay, so this is the basic of a command line application using Micronaut. And now we need to do the heavy work of connecting to the client, so to the server, so we need a client. So I'm going to use an interface for that, and we're going to call that Mastodon client. And because it is a declarative client, I'm going to use this @client annotation, and then we need to pass the base URL to connect to, right? So in this case, the URL that we're going to use is the server that I am using because I'm going to connect to my server. And but we don't want that to be hard-coded into the binary. So we put a token there, which is the configuration of the server URI. And there are two options to set this property. So either we go into the configuration file of the application and we have there Mastodon server URI, and then we put the URI there, but then it would be again packaged into the application, which is not something that we want, because we want that to be portable to other servers. So we just don't do anything there, but what we're going to do instead is that this property is going to be provided via environment variables. So I have an environment variable set, which is Mastodon underscore server underscore URI, all uppercase, which actually sets that. And because we have that, Micronaut would automatically map it to this property. So very neat, and you have nothing to do. It's just there for you. So in order to be able now to list all the statuses and to post a status on my server, I need first to know the internal ID of my username. So so why do we need to do that? Because if you look at the API of Mastodon, which is very well documented, if we look at the status and say that we want to view a status, Then you need the ID, but the ID is actually long ID, right? So we need to change that, and we need to have something which will map the internal string ID into the internal long ID. So we're going to add this method, and it works on the account API. So I'm going to just do this. It's a get method. This is the URL that you have to use relative to this API v1, and then this token is actually replaced with this parameter. So when we call this method, it's going to call that directly. And then we need to set up a record for the return type, which is basically the JSON and that we are going to have, and it's going to be an account, and it has a couple parameters, the username and the ID. And because this is going to be serialized on the wire, we added @double annotation, which comes from Micronaut serialization. So what we have now is a client which is capable of looking up an account, but now we need to be able to list the status and to post a new status. So I'm going to add a couple more methods. So the get status list is actually using this long ID that we obtain from the account, and it needs that there as a parameter. And then the post is actually simpler in this case. But again, we need to have a class to represent the JSON payload, so we need the record status. But the problem there is that if we look at the API of Mastodon, which is there, and that we look at the status, it is pretty involved. It has lots of different fields. Some are optional, some are not. So I have prepared everything before so that we don't have to do that live. And I'm just going to copy this so that you don't have to do all the hard work yourself. So this status now we have nullable fields, we have dates, etc., and you can see what I was explaining before, that we can use JSON specific, the Jackson specific annotations there. However, at runtime, it doesn't matter because Micronaut serialization will have converted everything into something that you can use. There is one last thing that I have to do, is that obviously I don't want anyone to be able to post to my own timeline, right? And so it means that the API is protected, and it is protected by a token, an authorization token. So I won't show you how you create a token in Mastodon today. It is really not complicated. You go to the admin interface and you can generate an application token. But basically what we will need to do is to send that token on every HTTP request that we're going to perform. So to do that, we need to create a new class, which I've named Mastodon Authorization Provider. And this provider implements HTTP client filter, and what it lets us do is that I can inject this property again to this authorization provider, and then use that when I'm going to send all my requests, and set that as a bearer token. So it means that again, this is something that I don't hard code into the configuration application.yaml. This is something which is available locally on my machine as an environment variable. So don't be surprised if you check out the code after and don't set these as properties locally. It will not be able to connect. So now I'm going to write some tests to make sure that we can actually connect to the server and read some statuses. So for this, I'm going to copy a test that I have locally and annotate this test now with @Micronaut test. So when I do that, it makes all the machinery that Micronaut is able to do, so all the dependency injection mechanisms available to test, which means that in practice here, I am capable of injecting the Mastodon client into my test and using that directly. So I inject the client, and then in the test, what I can do is just look up an account. If the account is something which is not known, then I must make sure that the result is empty. But if I look for my own username on that particular server, then it's going to return the internal ID, the long ID. And that ID, I can use that in the next method, which is called getStatuses, to list the statuses, and it shouldn't be empty, it should print a number of things. So if I run this test from the ID, it's going to fail because these environment variables that I talked about are not set. So it's going to fail saying, oh, sorry, this is not, this property doesn't exist. But if I do that from the command line, then I have these properties set. So I'm going to do Gradle-t test, run the test, and now the test should pass. Build successful. You don't trust me, so I'm going to use == 0 instead. Save the file. It's going to run the test again, and it should fail. Now it fails, right? So very easy, very easy. We didn't have to implement the client. We just said, this is the methods that you care about, and that's it. So that's the whole magic of Micronaut in action. Everything is done at build time and super optimized. So we still miss one piece in our demo, which is the actual command line tool that we want to implement. So to do that, I'm going to update the command there in order to add all the options that we care about in this demo. So again, I'm going to copy and paste code that I have written previously so that we don't have to care about all the details. But what I've changed is basically the options. So I added a couple options. -u is the user to retrieve the status from. And then the second option is this -p that I've used in the beginning of this demo to post a new status. And then the run method is a bit different. So basically, if the status is set, so if -p is set, then I'm going to call the client to post the status. Otherwise, it means that I'm in a lookup mode, so I just want to display the list of toots, and I can do that and look up the account and then get the statuses, and for every status, just return something. Um, and the cleanup code that we were talking about in the beginning is there. So GSoup is going to clean up the actual content of remove all the HTML tags typically. So I'm going to update my build script now to use args-u and then my username, because what it should let me do now is do Gradle run and see the result on the command line. There we go. Okay, so we have this list posted, but this is Java. This is pure Java. This is an application compiled with Java, executed with a JVM, etc., etc. So this is not what we want. What we want is actually to generate a native binary. So what we can do instead of run is to do Gradle native compile, and this is going to do something which is actually compiling the application using the regular Java compiler. And then it's going to use this tool called GraalVM native image, which is going to take the bytecode and convert it to a native binary, which is specific to my machine. So this process takes a bit of time. It should take around a minute. And basically what it does is analyzing the whole application, and from an entry point, figuring out which classes are going to be called at runtime, and then recompile that into a native binary, which will be self-contained, executable without any JVM locally compiled for this particular machine, etc., etc. And this is the application that I used in the beginning. So in the beginning of the demo, the output, the Mastodon CLI command line that I used, is exactly the output of this task, native compile. So we're going to see in a minute just the result. It's a bit slower because of the recording, I guess. Uses a bit more resources. There we go. So it created a native binary. You get some informations about what is packaged in the application, um, and it tells you where the binary was written. So we can actually list that directory, and we can see that we have a native application which takes around 60 megabytes. It is not optimized right now. You can pass flags to shrink that a bit more if you want to. But basically, this is a standalone executable. So we can try that and call Mastodon CLI, and it tells me, well, use this. But you can see already that it was super reactive, right? It was instant. So now if I do -umelix, then this is exactly the list of things that we wanted to see, all the messages that I posted recently. So we have a native binary, and it runs, compiles all on the machine. Last thing I want to show you is that actually here we have a test, which is @Micronaut test, and this is a test written in Java, but we can actually run this test in native mode. So instead of doing Gradle native compile, I could also use native run, but it doesn't really matter there. I'm going to use native test. And when I do that, Gradle W, sorry. When I do that, then it's going to compile my test into a native binary. And then this code is going to be compiled as native and execute as a native binary. So the test suite itself can be compiled as a native binary. So it's going to take again around 1 minute, but once it's done, then basically what it lets you assert is that everything that you've written works in a native world too. So um, you would typically not do that on day-to-day development, but this is something which is actually interesting to do on your continuous integration server on CI because, well, you have time, then it's in the pipeline, you can add that, you can run that maybe once a day if you want to. Um, but basically what it allows you is to make sure that the binary that you produce, which is a native binary, behaves the same as the binary which would be pure Java, right? So there are always some subtleties that you have to take care about when you implement native binaries. So this is a good way to actually check that everything works as expected. So now the binary is compiled, and you can see that the output is a bit different, but basically we have everything there, the status and the test output tells us everything which was executed. Just containers there is not Docker containers or whatnot. It's containers in the terminology of JUnit, so a test container. Well, that's all I wanted to show you today. Hope you enjoyed that. I'm going to post all the sources for this project on my GitHub. So yeah, don't hesitate to come and share. And thanks for listening, and take care. Bye.